Alright guys, welcome back. So the first thing we're going to do is actually check out the camera, and as you can see from the last episode, it is pretty good looking, but someone made a comment and mentioned it is a tad jittery. This is because we're using a lerp, and they mentioned I should use a smooth damp instead. So we also have the problem of this. As you can see, the camera is able to actually go into the models in the world, and that does not look very pretty. So let's correct that. But first, let's fix the jitteriness of the camera. So we're going to go into our camera handler script. Okay guys, go on your follow target method, and you're going to see here we just have a lerp down here. So first we're going to go up here and we're going to add a private vector3. That's going to be camera follow velocity equals vector3.0. Then we're going to come down here and we're going to do a vector3 smooth damp. It's going to be the same as last time. It's going to be between the my transform dot position and to the target transform dot position. And we're going to put in the reference for our camera follow velocity. And then just by the delta divided by follow speed. I'm actually going to move that down a bit because it is kind of at the end there. Make it a bit easier to see. Okay, perfect. And looks good. Alright, we're going to save that. Let's jump in the game there and try that out. And that is a lot smoother. So thank you very much for that suggestion, my friend. And upon checking the documentation, it actually does suggest that you should use smooth damp for cameras over lerp. So thank you for that. Alright guys, now onto the main topic of the video. We're actually going to create a collision function for our camera. So if it collides with any objects in the environment, it won't go up inside them. It will actually just, collide off of them. So we're going to create a private float for a target position. We're going to create a public float for camera sphere radius. We're going to create a public float for camera collision offset, and we're going to create a public float for minimum collision offset, and we're going to put all those at 0.2f. Save that. Alright, great. Now let's actually start a function. So we're going to make a private void and call it handle camera collisions. We're going to pass the float delta as we usually do. We're going to say target position equals default position. We're going to make a raycast hit variable called hit. We're going to make a vector3 direction equal camera transform dot position minus camera pivot transform dot position. Next, we're going to do direction dot normalize. Next, we're going to say if physics dot spherecast bracket camera pivot transform dot position camera sphere radius, direction, out hit, math f abs, target position, and then we're going to throw in our ignore layers from the previous video so it won't contact these layers. We're going to say float distance equal vector3 dot distance bracket camera pivot transform dot position comma hit dot point. Then we're going to say target position equals minus distance minus camera collision offset. Next we're going to say if math f dot abs bracket target position is less than the minimum collision offset, then target position equals minus minimum collision offset. Then we're going to say camera transform position dot z equals math f lerp camera transform dot local position dot z comma target position comma delta divided by 0.2f, and then camera transform dot local position equals camera transform position. Now I'm probably going to change that lerp to a smooth damp, but we'll see how it works out. If I do, I'll do it in the next video. I made a mistake here. Oh, there's not supposed to be a period right there. And that's supposed to be a capital P. My delta is not. Oh. Yes, there we go. Delta. Okay, so let's save that. And now we have to call it somewhere. So we're actually going to call this method in our follow function. Alright guys, let's talk a little bit about the code here before we move on. So what we have here is a sphere cast, okay? And if you guys don't know what sphere casts are, check out the documentation. But basically, they're just a kind of like a ray cast, very similar. It's a sphere that comes around the camera, and if it intersects with any colliders in the game, it returns true. Colliders being, of course, our game's environment. So the first thing we have here in the sphere cast is a float distance, and it equals a vector 3.distance. And a vector 3.distance being a distance between point A and point B. Point A being your camera's pivot transform, and point B being the hit point of the sphere cast. And then the target position is going to equal minus the distance, which is a combination of our camera pivot transform position and our hit point, minus the camera's collision offset. And basically, if the absolute value of the target position is less than a minimum collision offset, that target position equals minus minimum collision offset. And then we're just going to lerp that, the camera transform.local position, to the target position. And that's it. So if you don't understand this, you should really check out the documentation, but essentially, that's just going to make our camera bump off of objects in the environment. Alright guys, we're going to actually call handle camera collisions now under the follow target function. We're just going to pass the delta and we're going to save that. Let's minimize that and drop in the game, but first, we're going to change the camera holder and the camera pivot layers to controller. So you can keep the main camera on the default layer, at least I did, but make sure you put the camera holder and the camera pivots layers on the controller and start the game. So we're going to see your camera is now on the floor, and that's because of some functionality in our handle camera collision script. So now we're going to adjust the camera's height on the Y axis of the camera pivot child object. So if you ever want to change the camera's height, you have to go to the camera pivot and adjust it on the Y. If you want to change the Z, it's still down on the main camera. And I think I made that a little bit too high there, so I'm actually going to bring that down to 1.65, we'll say. And I'll start that, and that looks perfect. Okay, cool. Now, turning the camera, we'll see the camera actually rides off of colliders in the environment. It no longer goes through it. So that looks a lot better. We're going to end this video here with this glorious man's face staring into your eyes. Thank you for watching. Please make sure to drop a like. Helps get the video around, guys. And our next topic will be rolling and sprinting. So be excited for that one. And I'll see you guys soon in the next video. Peace.